Welcome to Eagle's Concept Learning Room. In this video, we want to take you through computer and calculator. This is a topic that also appears in both papers, paper 1 and paper 2. Please like us on our Facebook page, Eagle's Concept Academy, and don't forget to subscribe to this channel if you are watching us for the first time. If you have not yet subscribed, please hit the subscribe button to get access to more of our content, which will definitely help you in the exam. We are uploading content on a daily basis or on a weekly basis. Thank you so much, and follow me as I take you through computer and calculator. All right, some few points to note about computer and calculator are as follows. A computer is an electronic device capable of accepting data, processing it, giving it out, and storing it for future use. So there are a lot of things that can be computers, ranging from phones, laptops, and some other small electronic devices. So any device that is capable of accepting data, processing it, giving it out, and storing it for future use qualifies to be called a computer. All right. Computer language is known as algorithm. So in grade 9, they call it algorithm. But when we proceed and go to the grade 10s to 12, we'll begin to call it pseudocode. So now a pseudocode is simply a sequence of activities to be processed in order to achieve a desired outcome. In other words, it is a step-by-step set of instructions to carry out a certain function. So please mark my word, step-by-step set of instructions to carry out a certain instruction, okay, a certain activity. We're also going to encounter what we call a flowchart. So a flowchart is simply a graphical representation of a problem solving process. It gives a step-by-step procedure for a solution to a problem. So now, when we go to paper 2, we are going to be converting from a pseudocode to a flowchart and vice versa. So the procedure will be as clear as it can. All right. So in a flowchart, always remember that we use symbols instead of full words. Now, the symbols that we use here, they are acceptable standard symbols, not your own symbols, but something that is acceptable and standard, as you will see as we begin to solve through the questions. All right. So now, computer and calculator at grade 12 level is based on these 4 symbols. Once you understand these 4 symbols, and you can answer any question that can come under computer and calculator. So the first shape here is an oval shape. So this one, it is used to start or stop the program. So whenever you are starting the program, you have to use this symbol. Then inside this symbol, that is where you have to write the start. Okay, so you write the start. Then in here, this one is a parallelogram, which is an input. Okay, this one is used for an input or output. So it is used for input or output of an operation. Okay, input or output. That is the use of a parallelogram. So anything that you are inserting into the computer, anything that you are adding into the computer, it falls under input. Then we also have a rectangle. This one, it denotes an operation to be carried out. So in short, formulas is what you're supposed to put here. So allow me to mention that whenever you are dealing with computer and calculator, it is very important that you know the standard formulas, because they are the ones that you're supposed to input in order to get a desired outcome. All right, last but not the least, we also have a diamond shape. So this diamond shape, it denotes a decision. So here is where we put questions. On the pseudocode, it is found as a condition. It begins with if. So when it comes to putting in here on a flowchart, we change the if to is, and it becomes a question, which usually requires a yes or no answer. So here there will be a yes, and there will be a no. So you will see how these things are going to be applied. But once you understand this, then it means that you'll be successful in completing the course about computer and calculator. All right, let's look at some sample questions that come in paper 1. So paper 1, they bring 2 marks, and paper 2, they bring 5 marks. year in, year out, this is what is going to happen. Okay, even in your exams. All right, the question reads, in the answer space below is an incomplete simple program pseudocode for calculating and outputting the volume of a cylinder V. Given the base radius and the height h, complete the program by filling in the blank spaces with appropriate statements. Now, first and foremost, we need to know the formula. So volume is given by, so we need to memorize the volume for a what? For a cylinder. Okay, so here they are saying incomplete program pseudocode for calculating and outputting the volume of a what? Cylinder. Now, volume of a cylinder V is given by base area, which is pi r squared h. So this is what? This is the formula for the volume of a cylinder. So now, pi, it is something that is embedded on a calculator. So the only value that you would need to put under the input in order for you to know the volume, you need to know the radius and the height, just as we have been given in here. We've been given h and we've been given what? R. So these are our input. All right. And every time you're trying to sort out something, we always start with the begin. So like here, they've done begin for us. Then on enter, we just have to say enter R and H. So R, comma H. This is what we are entering. Then here where they are saying V is equals to, we just now put the whole formula. So pi R squared H. And your 2 marks is that. It is that simple and straightforward. Second type of question, the diagram in the answer space below is an incomplete flowchart to calculate cos x for the triangle shown below. So like I said, you need to be knowledgeable about different subjects and their formula. So here we are talking about trigonometry. So now, if we want to find cos x, what they did is, this one will be x squared is equal to y squared. So x squared is equals to y squared plus z squared. Okay, so x squared is equals to y squared plus z squared minus 2yz cos x. Okay, 2yz cos what? X. Now, since they are saying for cos x, meaning we have to make cos x subject to the formula. So this one is going to be x squared minus, this one crosses here, it becomes minus y squared. Even the z crosses, it becomes minus z squared. Okay, is equal to negative 2yz cos x. 2yz cos x. This is what it is going to be. Then since we want cos x to be the subject of the formula, we are going to divide here minus 2y and z. Okay, even this side we do the same. We are going to have minus 2y and z. So this and that will cancel. So finally we are going to have cos x. So cos x being equal to, now this negative divided by this positive that is in front, we are going to have negative x squared there. Then this negative times the negative there, we are going to have plus y squared. Then also this negative and this negative, we are going to have what? We are going to have plus z squared. Okay, so over, then the negative down there has changed. It will remain minus, it will just be 2yz. So this is the formula. Remember, we're just making cos x the subject to the formula. So rewriting our formula, finally, we are going to have cos x. So cos x being equal to, this is cos x being equal to, we always start with a positive. So we're going to say this one is y squared plus z squared. Okay, y squared plus z squared minus x squared. Okay, so y squared plus z squared, then over, this is 2y and z. So this is the formula. So having come up with this formula, then you go now and fill in the table here. So as usual, there is begin, then here enter. So in here, we are just going to write enter, because in your formula there, remember, in this rectangle, you are supposed to put the formula. So that same formula which we have found there, the cos x is equal to, so this is y squared plus z squared. So y squared plus z squared, then minus x squared over 2y z. That is what you put in here, and you filled in, you have your 1 mark. Then enter here, it is just going to be x, y, and z. These are the things that are on the formula. We have y here, we have z, and we have x. Once we enter this, the computer is going to compute it here using this one, and then you're going to output cos x, and you are done with this question. All right, let's look at this other example also, which reads, the diagram below shows a flowchart for a program to calculate tax on an income. So here they are telling us start, enter the income, then here you ask yourself a question now. Is the income less than 3,000? If yes, then tax is 0. So this simply means that for those people who get paid 3,000, they don't get any tax, okay? Then for those that get tax, for those that get a salary of more than 3 pin, they get tax. And now, how do you calculate tax? You use this formula. Tax is, this is a formula which is in the action box here. So tax is equals to 0.3 multiplied by income minus 3,000. Okay. Then after you do that, you are going to now find the tax, and then you stop. So they are saying complete the table in the answer space below. So this one here, if the income is 2,900, so 2,900, this one here is income less than 3,000. Now 2,900 is less than 3,000. So if yes, then tax is 0. So definitely in here we are putting what? 0. Okay, so this is the use of computers. They are using it. ZRA is using this method actually to calculate the tax on people that are working, whether in government or in the private sector. So that is what. Now, if is the tax less than 3,000, if no, of which here 5,000 is not less than 3,000. So to calculate the tax here, now we are going to say, okay, tax, like they are saying, tax is equals to 0.3. Okay, so 0.3 multiplied by, then in the brackets there, we are saying income, of which under income we have 5,000. So that 5,000 here, 5,000 minus 3,000, 5,000 minus 3,000. This is paper 1, no calculator. So we are getting something like 0.3 multiplied by 2,000. Okay, so 2,000. Here when we subtract, we get a 2,000. So let's multiply now. We are multiplying 2,000 like that. 2,000 multiplied by, just write it as 0.3. Ignore the point. Then let's multiply. So this times that is 0. Then 3 times 0 is also 0. This times that is also 0. Then 3 times 2 is what? 6. Then you add a 0 here. Then you are going to have 1, 2, 3, 4 zeros. So 1, 2, 3, 4. Because anytime you multiply something by 0, you always get a 0. So then you add there. You add. So 0 plus 0 is 0. 0 plus 0, 0. 0 plus 0, 0. Then here 6 plus 0, 6. Then you have a 0. Now remember, there was a point that we ignored. So now it is 1 decimal place, meaning we are going to do this, and this is it. So we have a 600. So meaning this person will get a tax of what? 600. And this is how you solve such questions. So this is just an example of question that comes in paper 1, which carries 2 marks. Now we are going to go to paper 2, where they can bring you a pseudocode. You convert it to a flowchart, or you convert a flowchart to a pseudocode. So please follow through and pay attention to every little detail that you'll be given on how to do these things. And once we are done, then we are warm and dry to sit for the exam.
The specific objective we are trying to achieve in this lesson today is on how to convert a pseudocode to a flowchart. So before we can dive into solving the question, just a quick reminder of the 4 basic things that you have to know about computer and calculator. So you already know what a computer is. It's simply any electronic device that can be used to input data, that can be used for processing data, it can be used for storing data, and so on and so forth. Then you also have to remember that in a computer, we have what we call the inputs, the things that you put into the computer. Then we also have the things that we call the outputs, the things that the computer produces after processing the data. For example, after you input a song into the laptop, then the laptop is going to produce sound. So sound is an example of outputs. So, okay, now to successfully solve questions that come in your exams every year, it doesn't miss, we have to always bear in mind the meaning of the 4 basic symbols under computer and calculator. So the first symbol is the oval shape, which simply means start or stop. So when you're starting, you can start with this one, and stopping, you can also stop with this one. So the other names for start and stop is the begin and the end. Then we also have an input. So when you're trying to put in to show the inputs, this is where you put them in. This is a parallelogram. Then when you're also trying to write the outputs, the things that are being displayed by the computer, you have to write them in this box as well. Another box, okay? You see how we can properly apply these things. Then we have the rectangle there, which is an action box. So in the action box, always remember, this is where you have to put a formula. It's that simple. Then we have a decision box. So in the decision box there, that is where we put the if conditions. So it's a question. So a question on the pseudocode, when writing it in here, it changes into a condition. Okay, so you will see how these things will be done. So like we are saying now, a flowchart is simply a graphical representation of a problem solving strategy. That is what we call a flowchart. Now, a flowchart, when we connect these symbols appropriately using some arrows, then it forms a what? A flowchart. Okay, so now going to the question that we are trying to practice now, in converting a pseudocode to a flowchart. Now, we have said a flowchart is a graphical representation of a problem solving strategy. Now, we also have to understand what a pseudocode is. So, a pseudocode is simply a step-by-step set of instructions that can be used to program a code, or in simpler language, a step-by-step instruction that can be used to perform an action. For example, if you are trying to show someone on how to turn on a TV, you tell them, okay, plug in, get the remote, press the on button, sit back, relax. At least if people follow those instructions, they'll be able to successfully turn on the TV and watch. So that is just an example scenario of what a pseudocode is. Okay, now let's look at a pseudocode that has been written on the board here and see how it can be translated into a flowchart. Now, this is one of the questions that comes in the exam, and it usually has quite a lot of marks, which you can't afford to miss. So as long as you follow us, understand this, you will never fail any question in the exam. Okay, so here we have simple start. We have said this one means start. Now, here, the question that is supposed to be here is, you are supposed to convert this pseudocode, you convert it into a what? A flowchart. So now, already things are straightforward here. Start, this is the start that we have. So you are going to write our start. So in the start here, so let me just write it this side. So start, then we put the oval there. Then the next thing they are saying, enter radius. Now, everything that you are entering into something, it is called an input. And the input box is this one. So you are going to connect using an arrow, then we'll do the input. So draw a parallelogram nicely. It shouldn't be questionable. Everyone should be able to see that it is a parallelogram. So in here, now, here on the pseudocode, you write the full words like that, radius. But when it comes to here, you are going to write only the symbols. So we are going to say enter R. Okay? Then you have to go to the next. Now, the next instruction now says if. Okay? So here they are saying if radius is less than 0. So now, the if, when it comes to the moment you see if, then you know it's supposed to go into the decision box. Now, the if here, it changes into is as you are putting it in there. So when you draw the diamond shape there, that diamond shape, okay, it looks like that. So in here, the if, it changes into is. Then is radius less than 0. So is, so here if, but so is the r less than 0. Okay, then there are two possibilities. It's a question. This is the question. So is radius less than 0? So there are two questions. They can either be that answer or that answer. So now here they're saying if radius is less than 0, then display error message and re-enter positive value. So meaning if yes, if no. So if it is less than 0, then you have to display. Now the display symbol is this one. So you have to display. So here now they're saying then display error message. So here you are displaying simply the error message. Okay, display error message and re-enter positive value. So re-enter, where you are entering from the error is here. So meaning the first error you entered was wrong. So you have to re-enter. That is where this loop now goes back. So you re-enter, you start afresh. Okay, so having done that, let's go to the next one. Now they are saying else enter height. So after this has happened, you re-enter the correct error. Now they are saying you enter height. So for entering also, it is a parallelogram. So we draw a very nice parallelogram there. So here also they are saying we enter height. So we enter the height. You put these things nicely as it appears there. If you want, you can put the word display error message, but the fact that you have put it in the display, it is already display error message. So you enter the height as they have said. Then again there's an if. So the moment you see if, then you know you have to make a decision. So the only place where you can make a decision from is in the decision box, which is the diamond shape. Okay, so you ask yourself, is the height less than 0? This is a question. So of course there should be a yes and a no. So now here it's a yes. So here's the thing, if height is less than 0, then display error message and re-enter positive height. So also here we are displaying the error message. So display error message. So this is the error message. You put it as it appears there. Then they are saying and re-enter positive height. So you haven't done, they are saying re-enter. So you go back and re-enter the correct height here. Then here it says else volume is equals to this one. So the moment you see a formula, then you know that you have to apply the action box, which is a rectangle. So the moment you see that one, you put in this one. Okay, so this is where we're going to say area, and like I say, on the pseudocode we find the words, but here we just find the symbols. So this one will be area half multiplied by r squared multiplied by height. That is what you're writing here. Okay, so we continue now. The other thing says and if display volume. So display already, we already know what the display is. It is this like that. So when you display now, so you write here now, you can write the word display volume or just write volume. So display volume and then stop. So from there you are expected to stop. So now the stop button is the off. So we have successfully converted from this pseudocode into a flowchart. So this is the flowchart and that is the pseudocode. Then in our next lesson, we are going to look at on how to convert now from a flowchart into the other way around, which is converting a flowchart to a pseudocode. So you already know what a flowchart is, and we already defined what a pseudocode is. But just for the sake of those that are joining us for the first time, maybe let me just go through one of these important shapes here. So computer lesson is just based on these important shapes that are on the board. So this shape here, the oval shape, it simply means start or stop. So when you are starting a program, this is where you enter, and when you are stopping, you also enter in a similar shape. Then when you are inputting something, we always use this parallelogram shape. Even when you are displaying something which is outputting something, we also use the parallelogram shape here. Then we also have an action box. To simplify things for the sake of your exams, we'll just say in the action box there, whenever you see a formula, this is where we put a formula. And in the decision box, that's where you tend to get to put the questions. So where you see if in the pseudocode, when it comes to writing a flowchart, this is where you say is. Okay, so you put a formula here, and also the success of writing any flowchart is dependent on an individual knowing the formula. So the first thing that you have to deal with is know the formula of the particular thing that you are dealing with. For example, if you want to write a flowchart to show how volume is calculated, the first thing is know the formula for volume. Once you know the formula for volume, then you can easily construct a flowchart. Okay, having given that background, let's just now continue. We go to the question that we have. So this question simply says, convert the following flowchart to a pseudocode. Now, a pseudocode has got a specific language that we use and a specific way of writing it. So please let me demonstrate and explain a few things on how it is supposed to be done. Okay, so here there is a start. As you can see, start there. So we start, you just write the start. Then the enter error. Here on the pseudocode we finish, we don't just write symbols. Here we finish. On the flowchart, that's where we write the symbols. So instead of saying enter error, as we're going to say enter radius. So it also doesn't start, it starts like you indent a bit, so it will start enter radius. Okay? Then you ask here, the is on the flowchart here, it changes to the if when you're writing a pseudocode. So here it's a question. If radius is less than 0, then, okay, so now here, if radius is less than 0, so here they are saying display error message. So if radius is less than 0, then display error message. Error message. Okay, display error message. Then they are saying error. Now, if we had enough space, we would have continued it there and written error must be positive. Must be positive. Then we go to the next one now. So here, every time before you write a formula, now you've seen an action. So before you write a formula, always remember to put the word else. So here we are simply saying else area. So we are saying else area is equal to this formula that we have been given here. Else our area here is equals to half multiplied by squared radius multiplied by sine theta. So you continue that side, which will be sine theta. Make sure you have enough space to be continuing these sentences. Okay, then before you can display what you are calculating, there is always this funny thing that is put, and if. Okay, and if, then that's when you say display area, because that is what you are doing. Then having done that, as a stop. So this stop should be in the same line there. Stop. And you are done. You have converted from a flowchart to a pseudocode. Now, you can do a quick practice of this one. You simply erase this thing and try to reconstruct it back using this to prove if what you have done is the correct thing. Okay? So, this is how simple it is. This is paper 2 type questions, but once you understand the paper 2 type questions, you can also easily deal with the paper 1 type questions, because they will just need you to know the formula and understand these 4 basic shapes, and you are home and dry. You are assured of the total 7 marks that comes in your final exam. That is 2 marks paper 1 and 5 marks paper 2. Thank you for listening to this lesson today. Till next time.